Beautiful concept related to the composite numbers. So if someone asks you how many consecutive composite numbers can you write, so here we can see that we can use the concept of factorial here. Like if here I have written some results, you can see 4 factorial I have taken for example, which is 24. So 4 factorial plus 1, it is 25. And we can see this is composite, this is also composite, this is also composite, this is also composite. So we are getting 4 composite numbers, but as we write 4 factorial plus 5, we are getting 29, which is a prime number, right? So we can see we are getting 4 consecutive composite numbers here, right? Between 4 factorial and 4 factorial plus 5, right? Similarly, I have written 5 factorial here, and I have done the same procedure here. I have got here 6 composite numbers, consecutive composite numbers, between 5 factorial and 7. Now here I have used here 4 factorial, and I have got 4 consecutive composite numbers. But here I have used 5 factorial and I have got 6 this time, 6 consecutive composite. So I was not able to find out any trend regarding it. So what I did, I tried to generalize it. So if we say n factorial, right, so which is equal to n minus 1, and we can see so on till 3 into 2 into 1, right? Now if we did n factorial plus 1, right, n factorial plus 1, so thus we are adding plus 1 to this number, right, plus 1. Now 1 is common here, 1 is also common here, so we can take 1 common out here, so we will get this as a composite number, right? Now if we add plus 2, so 2 and here 2 will be common, and we can do the 2 common out here and we will get something here, so this also will be a composite number. So we can do the same, plus 3 we can add, plus 4 we can add, plus 5 we can add, and we can go all till plus n, because as we do plus n, we can take the n common out here, right, and it will be a composite number. So from n factorial to n plus 1, n factorial plus n plus 1, yes, between these two numbers, right, between these two numbers I am seeing that we are getting n consecutive composite numbers, right? From n factorial plus 1 to n factorial plus n, we are getting n consecutive composite numbers. But the thing is, here we can see the 4 when we do the same with 4 factorial, we get 4 consecutive composite numbers. But when I did the same for 5 factorial, I am getting 5 plus 1, 6 composite numbers, like n plus 1 composite numbers I am getting here. But according to what I did here, this must not be the case. But when I did for some particular cases, like I did for 6 factorial again, for 7 factorial again, so what I noticed is that in 5 factorial, as you can see, why this 126, we have got this extra composite number, because the reason is, when we did here plus 6, this plus 6 is already present in 5 factorial, right? Because as we see, 5 factorial can be written 5 into 4 into 3 into 2 into 1, so 3 into 2, this is 6, right? So this was already present in this. So I came to know that as I have generalized this, so there can be a case when n plus 1, this n plus 1 may be present the number which we get by doing n plus 1 may be present among these factors, right? So how to generalize this? So I found out that if n is a composite number, right? If n is a composite number, then you can see that n factorial, we can write n minus 1 a similar way, right? So here we can write n factorial plus n at the last and take the n common out here. But as soon as we write here n plus 1, as we write here n plus 1, this n plus 1 is not present in any of any of the factors here, right? As we will take an example here, suppose 8 factorial, we can write this 8 into 7 into 6, right? And we take we can do here plus 7 till plus 8, but here I took 9 and 9 is present, I think, here, right? 6 can be written as 3 into 2, and here also 3 is present, right? So 3 into 3, 9 is present. We can take 9 common here. So this is also not the case. Then what we can do? So as you can see, I couldn't generalize the things here, because as you can see here 8 factorial, we have got till 8 and also got from 9. Plus 9 we can get a composite number. Plus 10 we can get a composite number. But when we do plus 11, we don't have any factor of 11 here, so here it becomes a prime. So what I could notice here is that if we take any number, any general number n, whether it be prime or a composite number, and we wrote here n factorial, right, from n minus 1 till 2 into 1, and we did here plus 1 plus 2. Okay, earlier I had said that we can take plus 1 and plus 1 common, which I know it didn't make any sense, right? So it's not also clear that if we did here plus 1, will that be a composite or prime? Actually I don't know here. So we can take plus 2, so we can take plus 2 also common here, plus 3 also common here, plus 4 also common here, right? So when we go till n, right, we